As we continue in this second recording on the same lesson, we're supposed to find a common denominator between 2x and 6x to the third. These are monomials. There's no pluses or minuses, so I don't have to think about my factoring skills. Instead, just use the skills you already have. The LCD, what would the common denominator be if you just had, say, 1/2 and 1/6? What would 2 and 6 both go into? 6. So I need a 6. I also need an x because both denominators have x's, but what power of x will I need? 3. I need the high power. That is my least common denominator. You can check it. Does 2x go into 6x to the third? Yes. Does 6x to the third go into itself? Yes. Then it is the least common denominator. The rule is you're going to need one of every different kind of factor. You're going to need the high power. Now, I didn't write it, but does everybody agree that 6 is really 2 times 3? So for the common denominator, you need a 2, you need a 3, and you need an x to the third. The 6 makes up the 2 times 3, and there's the x to the third. All right, these get easier the more you do. So let's look at number 5. Number 5 has 19 over x plus 7 and 14 over x minus 7. And the only thing that you're asked to do is find the least common denominator. Don't do anything with it, just find it. All right, this first denominator, this is a binomial. Can it be factored? Can you factor x plus 7? No. So it is a factor. It is a prime factor. Can you factor x minus 7 any further? No. The least common denominator is made up of one of every different or distinct kind of factor and the high power. Well, so what do I need? What do I have as factors? I need an x plus 7 and I need x minus 7. And neither one of them were squared or cubed, so I don't have any exponents. The least common denominator is the product of every different kind of factor that I had in the two denominators. That's your LCD. We're not doing anything with it yet. Let's look at number 6. I have 8x over x plus 1, and I have 16 over 7x plus 7. Can I factor the first denominator? Can I factor x plus 1? No. But that does tell me that there better be an x plus 1 in the common denominator. Can I factor the second denominator? Yes. Do you agree there's a common factor of 7? All right, so I'm going to rewrite that as 7 times x plus 1. And what is the LCD? What do I need? One of each different kind of factor that you saw sitting in the denominators. I need a 7, and I need an x plus 1. And I need that not to do that. Okay. It is. Okay, let me try to erase this. No. It is I'm having really trouble here. It is so Monday. See, every time one of those little boxes shows up, it's trouble. The LCD we're back. 7 times x plus 1. Is that okay? One of every different kind of factor. All right, let's go to the rest of the problems. All right, this is problem number 7, and I'm supposed to find the least common denominator for. I have 3x squared over x minus 6 in parentheses squared and 7x over 8x minus 48. I'm looking for the LCD. That's all I'm doing. What's the common denominator? Can I factor this, or is it already factored? It's already factored. It's already an x minus 6 as a factor 2 times. Can I factor the second denominator? Yes. What do you see? 8 as a common factor, and when I divide it by 8, I'll get x minus 6. So the LCD, I need one of every different kind of factor, the high power. So what do I need? I need an 8. I need an x minus 6, but I need it to the second power because if here it is a factor twice, here it is a factor once, I have to have it represented in the common denominator the most number of times, which is 2 times.
So you wouldn't add it together if I get to the third power?
No. Okay, very good question. Since it's one factor here and 2 factors here, should the common denominator be 3 of those? And the answer is no. Just take the high power. All right, let's look at problem number 8. I have 14 over 4x plus 4, and I have 15 over 3x squared plus 6x plus 3. If I'm going to try to figure out the common denominator, then I'm going to need to know the factors of each of those. Can you help me factor the first one? Do you agree the 4 is a common factor? And that will leave me with x plus 1. What about the trinomial that is the denominator of the second fraction? 3 is a common factor. So I'll take out the 3. That leaves me with x squared plus 2x plus 1. Do you think we can go further with that one? Yes. Keep the 3, and that is x plus 1 times x plus 1, which is really x plus 1 squared. I'm writing into my other problem. Okay. So I prefer to write it like that because when I'm figuring out my least common denominator, I need to be aware of exponents. Okay. So, common denominator. Well, let's just talk about all the factors we have. Do you agree we have a 4? We have a 3. We have x plus 1, but we have it represented twice, and this one has the higher power, so I would need this one. So, my least common denominator for all of that would be what? I need a 4 and I need a 3. So, what could we call 4 times 3? 12 times x plus 1 to the second power. I would not count it wrong if you said it was 3 times 4 times x plus 1 to the second power. But usually when you have monomials that are numbers that could be multiplied together, you do. Is that okay? All right, we have a couple more to do with least common denominator. Number 9. It has 16 over x minus 9 and 9 over 9 minus x. What do you notice about these two denominators? Opposites. So I'm going to make a note of that. And it's going to be a little bit easier to find a common denominator if you're dealing with opposites. If they were identical, it would be the common denominator, but it's not. Which one do you sort of not like? Which one looks out of order? Usually people say 9 minus x looks backwards. Do you agree that it would look better as x minus 9? But if I changed this to its opposite, do you remember our discussion during the last lesson about you can change two signs in a fraction without changing the value? Yeah. Two positions. I just changed the bottom to its opposite, which is okay as long as I make another change. How about I change that to its opposite? So I changed the bottom and I changed the top. That means I actually have done nothing to change the value of the fraction. But what's the LCD? X minus 9. And it is more traditional to use the one that starts off with the variable. All right, problem number 10. I think I'm going to go down here where I've got more room. Let's look at 10. I start out with 2 over x squared plus 5x minus 24. And my other fraction is 6x plus 7 over x squared plus 10x plus 16. If I'm going to find the common denominator of those two fractions, what will I have to do with each denominator? I have to factor it. Trial and error for both of them. The first one, I need 1 plus and 1 minus. I'm going to need an x and an x. I need factors of 24 with a difference of 5. 8 and 3. The 8 will be the positive and the 3 will be the negative. Second denominator, I need a plus and a plus. I need an x and an x. I need factors of 16 that add up to be 10. 8 and 2. The LCD. I need one of every distinct or different kind of factor. So what do I get? X what? X plus 8. I need an x minus 3 and an x plus 2. Should I have x plus 8 written as a second degree? Yeah. The answer is no, because it's not squared here and it's not squared here. So it's not squared in the common denominator. You only take the high power that exists, and there is no power other than a 1. Let's look at 11. Suppose I had 1 over x squared minus 36, and I have x plus 9 over 9x to the 9th minus 54x to the 8th. I'd like you to take a minute to, that's a 9, factor those and determine what you think the common denominator will be. What did you notice about the first denominator? What kind of a polynomial is that? It's the difference of squares, and it factors into x plus 6 times x minus 6. The second denominator, I hope you saw a common factor, 9x to the 8th. When you're factoring, it's the low power, but when you're building a common denominator, it's the high power. That leaves us with x minus 6. The least common denominator has to have one of every different kind of factor, highest power. So what do I need? 9x to the 8th. So you usually put the monomial factor down first. And then what else do you need? X plus 6 and x minus 6. Pardon me? When I'm factoring out the common factor, I look and I take the low power that I see, and I see an x to the 8th. So if you divide that by 9x to the 8th, you get x. And if you divide that by 9x to the 8th, you'll just get a minus 6. You don't use the high power until you're actually building the common denominator. And then you're looking at, do you have any other power of x plus 6? No. Do you have any other higher power of x minus 6? No, I have another one that's just like it. I do need a 9, and I do need an x to the 8th. It's if you had an x plus 6 here and an x plus 6 squared over here, you would take the squared. That's when you're building the LCD. All right, so that's all the practice in this lesson on finding LCDs. Now, if we refer back, we've added fractions that had common denominators. We made sure we reduced. Then we have practiced finding the least common denominator. Let me get you to think back for just a minute about, let's suppose we had, whoops. What if I had, I think I've mentioned it another time, what if I had 5/12 and I literally wanted to add 7/18 to that? What is the common denominator? 36. Now, we've talked about how you build common denominators, but let's just say that we got that common denominator. The next part of our problem is going to be to create equivalent fractions. You would look at this denominator, compare it to this denominator, and say there's a change. What was 12 multiplied by to turn it into 36? Do you agree? 3? And then you would do the same thing to the top. You would say, well, 3 times 5 is 15. When you did this, you built an equivalent fraction. On this one, you would look at the old and look at the new and say, what was 18 multiplied by to get 36? 2. And then you would multiply the old numerator by 2 to get 14. And you would have built a second equivalent fraction, and then you would go on about your business adding them. Well, as we go into our next problems, we're going to start with a fraction. We're going to be given a common denominator. We won't even know where it came from. We're just going to see it, and our job is going to be to figure out what the new top would be. So, as we look at 13, 14, and 15, that's what we're going to practice. Okay, I'm going to come down here, and we're going to look at number 13. Equivalent fraction. I tell you what, I really need to go ahead and, I think number 12 does this as well. Sorry. Let's suppose I am asked to build an equivalent fraction. And I start with 7t plus 5 over 24t plus 21, and they tell me to write it with a new denominator that is 3s times 8t plus 7. Okay, take a minute and write it down. In the big process of adding fractions, it would be as if this is one of your starting fractions. Somehow you got this common denominator, which you don't know how because you don't even know what the other fraction was. But somehow you came up with this common denominator. You need to know what will the new numerator be. If you were doing this in the midst of a problem, this denominator would have already been factored. But can we factor it right now? What's a common, or there is a common factor, what will it be? 3. So it'll be 3 times, 3 goes into 24t, 8t times, 3 goes into 21, 7 times. Okay, that would have already happened before this stage of the problem you were asked to do. This is your old denominator. This is your new denominator. What's the change? What do you see that this one has been multiplied by to turn it into this one? S. Wasn't it multiplied by S? That's the only thing that shows up that's new. So if the bottom was multiplied by S, the top needs to be multiplied by S. So this would be, can you use the distributive property? What's S times 7t? 7ts. Some people might write it as ST, putting them in alphabetical order, but it doesn't matter. And S times 5 is 5s. In your math lab question, this is the only thing you're going to be answering. What is the new numerator? And that's it. You have an old denominator, you have a new denominator, you're asked to identify the missing factor. Once you identify it, you multiply the top by it. Yes. Yes. Sure. If you can see that, then you won't write down as many things as I do. But we're going to have plenty of problems, I think, where you won't necessarily see it. All right, let's look at the next one, number 13. This is such a Monday. Yes. All right, suppose I have c over c to the third plus 7c squared plus 10c, and I would like to turn it into a fraction that has as its denominator c times c plus 5 times c plus 2 times c plus 4. This is my old denominator, this is my new denominator. I cannot really compare them right now because my old one is not in factored form yet. So what do you see that maybe we could do to factor this? Yes, we see a common factor, first of all, of c. And that'll give me c squared plus 7c plus 10. Do you think maybe there's more we can do? What are the factors of this trinomial? I need c's, I need plus signs. Won't it be 2 times 5? So I factored it and got out the common factor. I factored the trinomial. So now I am comparing my old denominator to my new denominator. And will you tell me what you see as the new factor? It evidently has been multiplied by c plus 4. So if the bottom was then the top needs to also. What do you get? C times C is C squared, and C times 4 is 4C. And that's what you'll fill in my math lab. You're asked to create a numerator that is equivalent. Okay, last one of this set. Pardon? Yes. This is the old fraction, the new fraction. You see what has happened to this to turn it into this, and you see that a C plus 4 got multiplied by all of this stuff, so you do the same thing to the top. C plus 4 times C, using the distributive property, should give you this. Okay, last one in this set. Number 14, I have negative 2y plus 6 over 30x squared plus 30 equals something over 60x squared plus 60. Now I can do I can do some factoring. By the way, this is the first and only denominator in this group that didn't come to you factor. This one would factor into 30 times x squared plus 1, which does not factor any further. The new denominator is 60 times x squared plus 1, and it doesn't factor any further. If you compare the old to the new, how has it changed? What has it been multiplied by? By 2? And this is another one of those problems where you might not have needed to do the factoring to see that. You might have just looked at 30x squared plus 30 and 60x squared plus 60 and said, oh yeah, that's been multiplied by 2. So if the bottom was multiplied by 2, the top needs to get multiplied by 2. And when you multiply this numerator by 2, what do you get? Negative 4y plus 12. And you have now built an equivalent fraction by filling in this numerator. Is that okay? All right, those are the skills that you're going to need. You're going to feel or remember us doing each one of those as we get into section 7.4. When you take a test over chapter 7, which for this in-class group will be at the end of this week, you will not have any questions specifically from 7.3. They're just used in 7.4. Okay, so we'll call it this one done.